Right, so I'm going to explain electromagnetic induction, but before we start, just imagine your place is just hit by an earthquake or tsunami. What would you do? There's no electricity and you urgently need to charge your mobile phone so that you can call for help. How do you charge your mobile phone without electricity? You had to create electricity. How do we create electricity? We will see in a minute. Right, so think about a magnet first. Every magnet has a mysterious magical field around it. You can't see it, but if you can see it, you will see these lines. These lines leave from the North Pole and enter the South Pole. These lines are called a magnetic field. So if you have a North Pole of one magnet and a South Pole of another magnet, these field lines will leave the North Pole and enter the nearest South Pole that they can find. So that bunch of lines is known as the magnetic field lines. And if you take a piece of wire and move it inside these field lines, that wire will suddenly start acting like a battery. It will have a voltage and it can actually power things. So suddenly we've got electricity. Just a plain piece of wire, move it inside a magnetic field, and that has a voltage on it, and it's got electricity. So we can power a light bulb just by taking a loop of wire and moving it inside a magnetic field. So if you rotate a loop of wire inside a magnetic field like this, we can create electricity. In fact, this is how dynamos work, and this is how all the generators work. They've got some magnets, they've got some coils, and one of these things move. They either rotate the coil or leave the coil as it is and rotate the magnets. One way or the other, the field lines cross the wire, and that creates a voltage. Now the direction of the voltage is going to depend on which way the wire is moving. So if the wire is moving up, for example, the current will flow in one direction, but when it goes down, it will flow in the opposite direction. So as this loop rotates again and again, the direction of the voltage is going to change. When it is going up, it is one way. When it is going down, it is the other way. So this voltage, because it's going to change direction all the time, is known as an alternating voltage. So it can be zero, it can increase, decrease, go in the opposite direction, come back to zero. So it's always going to go up and down, up and down. If you have many turns, if it's like a coil with many turns, that will create a lot of electricity compared to just having one loop. So the more turns you've got, the bigger the voltage. And you don't always have to rotate the coil. You can keep the coil fixed and rotate the magnet as well. Again, the field lines cross the coil and you get electricity. So that's how dynamos work. Thank you.